Baby going. Hi there, my name is Boyd Lake. This is my final presentation for, let's go to the top here. For CIT260, it's object-oriented programming, Java. It's been a good class. Let's get started because there's a lot to show. First of all, the static class variable and the non-static instance variable. These are variables that are defined and are members of the class, but they behave a little bit differently. The instance variables, they belong to an instance of the class. These are the variables that go along with the objects that are instanced. And they can have their own values, and they don't affect any of the other instances of the class. And most of the objects that we dealt with were designed like this. The class variables are different. These are class-defined variables, and they're a variable that if you change it for one, you change it for all. It's like having a class for cars, and there's a variable that defines that cars have 4 wheels. And if you have a minivan and you want to change the number of wheels on the minivan, well, if it's a class variable, you're going to change the number of wheels for all of your cars. So you might, if you need to do that, you might want to make the wheel variable an instance variable if you want to not affect everything else. But that's how variables that are static and non-static or instance variables behave. Methods are very similar. A static method is called by using the name of the class and the name of the method like this. You call just the class name first and then the method name. The non-static methods are instances, or they require an object instance for you to be created so that for you to be able to get to the method. So you first have to instance the object, and then you use the new object name at the beginning, and then separated by the period, and then the method name. And that's how you call a non-static method. This is an example in my code, or in our code, of this two very similar but different things in this way. If you look at this create player class toward the bottom, there's a static at the bottom, a static method being called, and then there's a constructor, a non-static method called just above it. The player equal new player is a constructor of an object instance, so that the player set name function can be called. And so that's a non-static method. That's the way you work with those. The static methods, you just use the name of the class where the function is defined before the name of the function, and that's how you call that. So that's the difference between calling static methods versus non-static methods. Arrays, array lists, and enums. These are interesting. The array is just a list, and it's a fixed size, and all the data in the list, or all the objects or values, are all of the same type. But they can be empty or null, or each index can be empty or null, so they can change. But they're fixed length, and they all have to be the same type. The array list is different, and the array list is also contains only objects. But the array list is not a fixed length. It can change size or length, excuse me, and you can mix object types in it as well. So they don't all have to store, every piece of it doesn't have to be the same. But you have to remember the array list is a Java class, and that's why it stores objects. An enum is a fixed list of objects of the same type, and the list never changes. The objects or values are constant and remain so. They can be referenced by index like the other two. Similarly, they use an ordinal system, which is essentially an index, but you don't really need the index if you know the name of the constant, and you can get right to it without worrying about an index. And these are examples of the different types of lists and arrays that I've used, or that we've used. The weapon list array is just a linear or single dimensional array. And that's my weapon list. The medkit count array is a two-dimensional array, and most of the arrays, excuse me, that we use in our game are two-dimensional, and they're just based. This is because our map is two-dimensional. We have different locations that are arranged on a grid, and so the two-dimensional array is perfect for dealing with where you are and tracking where things go. So there are quite a few arrays like this in our game. The array list here is, we have a weapon list that needs to grow and shrink. They're all strings, but it just needs to be that flexible, and so that array list is a piece of code that we have in our game. Also, the enum class. Enums are stored in classes, but that's an example. This one is a list that's been cut short, but these are lists of the scene types in the game. To parse through or step through the elements in an array, you use a for with an index. And this is an example of the code for one of the pieces of sorting through this weapon list array that I've got. It's the single dimension array, and it's this little menu has to be dynamic, and that there could be any number of weapons that the player has. And so this little for with the index is used to parse through the list, extract all the pieces of the array that have values, and then add them to the string that creates a new line, new lines in the menu that populates that list so that the user can select a new weapon. And that's how that goes. But there's an easier way to do this, and so I thought I'd add it. It's the for each. This was the original way I wrote it, and then I realized I didn't have a for index loop, so I had to rewrite it. So there it is. The for each is very good, especially for lists that change, like the array lists, and so that's why they get used a lot. But the code is much more brief. Okay, throw and catch, runtime errors. We did this in a few different ways. There's a stack trace, kind of a high-level catching of runtime errors that we did. The throw and catch for custom runtime errors we accomplished by creating our own exception classes, and then throwing errors using those classes. And it's done by using the try and catch methods, or not methods, they're just statements, blocks of code. The try executes a piece of code, and then the catch throws the exception if there's an error anywhere that occurs. And so that's how that works. This is a piece of our fight system, and so that's there. Then that's a look at the class that was built. It was largely automated with NetBeans, but that's a look at the overloading and different options for catching and throwing errors. This is a slightly different way. We also built a little class that would save errors to a file. And this is a look at how we used that. This was handy in that the user could largely go through the game and not be bothered with the errors too much, and they could get through the game. And then later they could open up the file and see where their errors were, and this also tells you what class that the errors occur in. So that was handy for that. And there's a look at the actual error view class where the error log files, error file and log file are made, and what gets sent to them. Pretty handy little tools. All right, byte stream classes versus character stream classes. A byte stream class is a binary stream, meaning there's very, very little bit of data, 8 bits or a byte, 1 byte at a time, and that's not a lot of data. This was the original implementations of Java had byte stream classes, and they had their limitations. They don't really adapt to other languages. Only Western languages are really supported by ASCII and the binary system. So it created problems as more and more folks started to use Java. So they created the character stream classes. And now there's so much better ways of streaming character data for languages, for the Unicode formats. You can save and write in all kinds of different formats, and these character streams will handle it. And Java recommends using only character streaming for reading and writing all character data. It provides formatting, which I found nice. So those are the basic differences between the two. Of course, there's more data with the character stream classes. I don't know if that means it runs any slower, but there's still quite a few streams that would need to be binary. A lot of the data with video and audio that we use are binary streams. So I would assume that byte stream classes are still useful. You just have to know when to use one versus the other. Writing data to a file. On the left is a little bit of code that I had to write for writing our map. I had stored our maps as ASCII string character data that was not formatted for writing to a file. So I had to build that little bit of code that would parse through each map line by line. Now it's a map that, it's the current map based on the location, and so it has to go out, find the right map, and then reparse it. It just reads a line or 71 characters at a time, and then spits out a new line with the correct formatting, and then writes the file. On the right is a scene report that includes a weapon. So I reference my weapons by damage value. So that's the reason for that little bit of code up at the beginning, and that's just a few of the weapons. There's quite a few more than that. I think there are 12. But that's just scene report, which means it goes and gets these different variables that are being tracked throughout the game, and then creates a little report for each scene that you're in. And there's a little stat report for the player, what the XY coordinate is, meaning what the location is on the map, the location scene name, and the current player health. Streaming in I/O requires a few basic steps. The first one is opening up a file, streaming to the file, and then closing the file. And so on the left is a sample of where I've opened up files in my main class, and at the end of that class is where the file closing happens, and of course both were important. Okay, well let's go look at the game real quick. This game we had a lot of fun with. We tried to be a little light and humorous. It's basically you wander through your map, are given certain clues about where you're supposed to go, and hopefully you can get to your destination before you die. And you are given different narratives based on the scene that you're in. So I'll type my name. Then there's an introductory message, nice little headstone, and we'll start the game. So each scene has a little narrative, and you start out with 100 health. Of course, at the very beginning, you don't have any zombies to fight, but you wake up and you're not sure what's happening. The street's empty. Anyway, you've got to figure out what to do. So there are options below. I'm going to start. First smart thing to do is to search the location. Of course, there's no inventory to be found except for a knife. So I'll pick up my weapon. So my knife has been picked up, and so I'll quit because there's nothing else here. And then before I do anything else, I probably ought to go select the weapon. So I view my weapon, and this is that dynamic list. Fists, I'd rather not fight with my fists. So I'm going to select the knife. The knife has been selected, and so I'll quit. That just means I can inflict more damage and not suffer so much when I fight. So I'm going to move, and this is the move menu. So I'm going to move to the right. And there's a new location. There's a school. And so it gives you this, you enter the school and survey the area. So you see some people huddled over a body near the tire swing. You can't really tell what they're doing. You shout to them and they turn to you. They are covered in what looks like blood. They start to approach you, making groaning and moaning noises. You think of one of them grunts the word brains. You nervously back away and draw your weapon. There are 2 zombies here. So I want to fight the zombies. And I've got my knife as my current weapon. And it's a pretty short fight. The zombies are dead and I only lost 5 health points. So I'm going to quit the fight. Quit moving because I want to search the area. And in this area I see med kits, energy bars, 1 energy bar and one water bottle and no weapons. So I want to pick up the items and then I'll quit and I'll go back to move. Oh, let's go back. Let's quit again because I want to show, so we picked up some items, but we haven't used them yet, so we must have inventory. So yeah, we have 4 med kits, a number of water bottles, and 1 energy bar. So I want to go down and I want to use my inventory. I use a med kit, and here the menu system doesn't report back like it should. I want to use a water bottle, and I want to use a energy bar. And I'll quit. So if I view inventory again, they're all gone because I used them. Now if I move, I'm going to have my health back. In fact, I've got more than 100% health. I'm really riding high. So there are no zombies here at the school because I've gotten rid of them. So I'm going to move to the right. There's a fire station. There's a little bit of introduction for this area, and then at the bottom it says there are 3 zombies here. So I want to fight the zombies. And I'm fighting with a knife, and it says, look at the zombies. This one here, her name is Marge. She likes flannel pajamas, sunshine, and brains. Zombie health is still 2, so I've got to keep fighting. There we go. Zombie health is 0, so I'm done with the fight. So I can quit fighting, I can quit moving, and I go to search the location. Oh, I can see med kits, and I see a new weapon, a machete. So I pick up the items, I pick up a weapon, I pick up, yeah, I've already picked it up. So it's not there anymore because I picked it up. So I quit, and I go and I view inventory. I've got med kits. I want to use the inventory. Okay. Med kits, water, energy bars. Quit. I want to view and select weapons because I got a new weapon. I have got a machete now. So I'm going to select machete, and it's been selected. So I'll quit. I've kind of lost track of where I am. So I want to look at my map. I see that my current location is the fire station. So I want to move. I want to move forward. I want to go to that convenience store. So I'm going to go forward. And the scene says there's nothing here, but there are 9 zombies, and that's quite a few. So I've got good health. So I want to fight the zombies, and I've got a decent weapon. It's a machete. It ought to be decent, but the zombie health is still 11, so I continue fighting. It's 9, so I'm only knocking them down by 2 at a time, and I'm counting down my health. Ooh, that was quite a bit. Anyway, I'm going to quit fighting the zombies, and I'm going to quit moving, and then I'm going to search the area. There's quite a few med kits. I want to pick up the items. No weapon found. Dang it. All right. I want to quit. You've seen, basically, once you get to the end of the map and you have gone through all this fighting and zombie fun, if you get to the end of the map, the refugee camp, there are quite a few zombies there, but you get much better weapons. You get a rocket launcher and a grenade. Essentially, if you can get to the end of the map, you win the game. But it's going to take me a while to get there, so I'm just going to cut it short. One thing I'm going to do is I'm going to save reports by hitting R, and I'm going to quit. Quit out of the game, and there we go. One thing I want to do is show the log text. These are the errors that are. There's a few things going on that need to be fixed, and this is in the fight view class. This message wasn't printing, so I know there's an issue I've got to go fix there. The map report shows me my current map based on where I was when I quit, and I was at the convenience store. So that's how that looks. The scene report generates the current weapon, my med kit count. Now these are items that I didn't use, that I had usable. So because my health went way down, the first thing I would do is go back and use that stuff to rebuild my health. And there's a stats report. Player health was down to 52. That's halfway down. That's quite a bit. And there's my coordinate in my array. X coordinate is 2, Y coordinate is Y. Anyway, that's a look at the game. I want to thank Evan Arnold and Katie Hall. They were very good teammates and were very helpful. They all contributed a great deal in making this game. Anyway, I'm sure I'm pretty long with this, but thanks for sticking it out, and see if I can go stop sharing and go to my Hangout.